Hello everyone, welcome to lesson 18 of our GoLang course. In this lesson, we are going to practice what we learned in the last lesson about slices with some code. I've written what we are going to cover in this lesson. First, we will be looking at creating slices or declaring slices, then the make function, followed by the pen function, and then nil and empty slices. So let's begin. First, I'm going to create a slice with int. A here is a slice of type int. If I do fmt println a is equal to nil and run program with go run main.go, you will see when I equate it to nil, it comes as 2. So this is how a nil slice is declared. As I told you in the lesson, a nil slice has no underlying array. But once I do this, you will see there's an underlying array, and if I try to print this statement again, it will come as false because it's no longer a nil slice, but it's an empty slice. So let's run our program and type go run main.go. You can see the first statement is true, where we are comparing a is equal to nil, and then the next statement is false after we assigned an empty slice to a. So that's the difference between a nil slice and an empty slice. I'm just going to comment this out. Before commenting out, let's write what we have written. This is a nil slice and this is empty slice. Now let's move on and see how we can declare and initialize slice with different methods. I'm going to comment this out before we move on. So we are going to look at different ways of declaring and initializing a slice. First, I'm going to use just the normal notation. I'm going to use the shorthand here and say I want an int slice, and we have already looked at the empty slice. So now I'm going to say I need values inside the slice 1, 2, 3, 4, 5. Cool. Now let's try and print it. Go run main.go. You will see the slice has been printed, and it says the values or the elements of the slice are 1, 2, 3, 4, 5 as we assigned here. As I told you before, we can also declare or initialize a sparse slice just like sparse array. So I'm going to say 5 as a first element, second index element I want it to be 10, and the last one to be 50. I can do fmt println a. Let's see what the answer is. Just going to clear the console, go run main.go, and you can see 5, 0, 10, 50 printed to the console. Here you see, since we declared a slice, the length has already been adjusted or automatically has been adjusted by go. Now let us look at the make function and how we can use the make function to initialize and declare a slice. I'm going to comment this out again. In the first form, we are going to create a slice of size 5 with all 0 values for our int. So I can say a colon equal make int slice of size 5 or length 5. If you haven't noticed until now, we use the square brackets to declare a slice or array. When there is a length inside the square bracket, it's an array. When it's empty, it's in slice. So let's try and print this out and see what output we get. Go run main.go. You can see all the 5 values have been initialized to 0. Now if we do len a, we should expect 5 to be printed to the console. Nice. As I told you before, you can also use a cap function to get the capacity of the slice. Initially, the capacity of an slice will be equal to the length of the slice. So if I run main.go, you can see 5 and 5 printed. We will see when we append beyond the capacity of the slice, the Go algorithm that is used by slices to manage the underlying array will increase the capacity or the length of the underlying array. Let's just comment this out. Next, we are going to create a string slice with length 5 and capacity 10. Now if I do a fmt println a, we will see again 0 values of string, which is an empty string printed to the console inside the slice. So go run main.go. You don't see comma separated values. That's another thing with println function. It doesn't print values of a slice or array in comma separated form, but there are 5 elements that are empty strings. Now if I do len a and then do the same for capacity using the cap function, you will see 5 and 10 printed. That's because when you use the make function, first is the type of slice that you want to create, the next is the length of slice, and the third is optional argument, that is the capacity of the slice. You can read more about the make function in the standard lib. I will add a link to the make function and its description in the video description. Let's comment this out and move on to our next section, which is pen function. We use the pen function to pen the values to a slice. So if I say a is a slice of type int and length 5 and then do fmt println a, we should see what we expect. that is 5 zeros printed to the console. Go run main.go. Nice. Now if I append to a, let's say I want to append 5, you can see the ID is complaining because we are not storing the return value. That's because append returns the new slice with the appended value. So what you would do is this, which says a is equal to the new slice with appended 10. Now if we move the print statement below append, then run our program, go run main.go, you will see the first 5 values are 0 and the next one is 10. That's because when we provide a length in the make function, all the 5 values or all the values up to the length are given the 0 value. So be careful when doing something like this. Instead, what you can do is create a slice of length 0. So this way, when you append it, it will be appended at the first index. Go run main.go, we get 10. Now again, let's see what the capacity of this is. It's 1. Now again, let's append more values to the A slice. As mentioned, you can append multiple values to the slice using the append function. Now, if I move this println statement below the append function where we have appended multiple values to a slice, let's see what the capacity is now. Go run main.go. You can see the capacity has been increased to 4. What if I append another value like this and move the print statement to get the capacity below here? Let's run the program. And you can see the capacity has been increased to 8. So Go automatically increases the capacity as needed. You can also use the spread operator to merge another slice into A. So let's comment this out and here say A is find slice with values 1, 2, 3, 4. Now I want to append some values from another slice which is P. Before doing that, I will need to create P. So I can say P is a slice of type int and values 10, 20, 30. Then I can use the spread operator to merge these values. So now if we print A, we should see A has both the values 1, 2, 3, 4 followed by 10, 20, 30. Go run main.go. As expected, we have 1, 2, 3, 4, 10, 20, 30. So this is how you use the append function to add values to a slice. Another thing I mentioned in the lecture was that always remember, you need to store the return value from append in the slice that you're appending to so that the new appended slice is assigned to A. Another thing I mentioned in the lecture was that if I have some function which accepts x as an int array of size 2 and then try to call the sum function here, I would need to pass an int array of size 2. I can't even pass an int array of size 3. So you can see this is a problem as Go is complaining about the type. That is because as we learned with arrays, the length lives on the type of the array. Integer array of size 3 is different from integer array of size 2. This is not the case with slices. So if I remove the length from here, it says that we will accept slice. So I can do this and it works. I can also pass A if I want with no errors. And I can also pass P with no errors. So that's the benefit we were talking about when we said the length of the slice is not tied to the type of the slice. Majority of the Go code that you see works with slices. It's only when you know that you only need a specific set of values that you see the use of array. That's it for the lesson. First, we covered the difference between null slice, which doesn't have an underlying array, to empty slice which has an underlying array but doesn't have any elements stored in it. Then we looked at different ways of initializing and declaring array. First one was just using the colon equal shorthand and saying I want a int slice and values 1, 2, 3, 4, 5. Next was a sparse slice like a sparse array, very similar. Notice the difference, we don't pass the length of the slice in there. Then we looked at using the make function to create a slice of length 5, then another one of type string length 5 capacity 10, then another one of type int size and 0 length. Then we looked at how we can append values to slice using the append function, how we can append multiple values, or how we can append values from another slice into an existing slice. So that's it for the lesson. As always, please practice this out and try things on your own. The more you experiment with this, the more you will learn about it. I hope you enjoyed the lesson. I will see you in the next lesson. Happy coding.